Hi, welcome to Imperium Learning. The topic of this video is going to be impulse response functions, and I feel that this video will be particularly useful because it talks about IRFs in the context of a vector error correction model. Now, before I show you how to apply IRFs on Eviews, what I want to do is I want to talk about IRFs and their applications. This is quite important actually, particularly because I'm talking about it in the context of a vector error correction model. So the first thing you should bear in mind is that before you apply your impulse response functions, you should first have applied Granger causality tests. The reason why is because they will explain the sign of the relationship as well as how long these effects required to take place. Now, IRFs as well, they can show how responsive a dependent variable is to a shock in an independent variable. So, moving forward, I should give you a word of warning, which is that generally IRFs are only really appropriate for standard VAR models rather than vector error correction models. And the question is, why is that? Well, the reason is because when you set up a VAR model, you input your variables in their differenced form. So in other words, they'll be stationary when you when you estimate a VAR model. This is actually in stark contrast to a vector error correction model, where you're inputting your variables at level. And unfortunately, because most variables are integrated to an order of 1 and therefore have unit roots, that usually means that you're inputting them in their non-stationary form. Now, why is that a problem? It's because basically, when you have a VAR model and everything's differenced and everything's stationary, when a dependent variable experiences a shock, it will return back to equilibrium over a period of time. So I just want you to think of this as like, I just want to use an analogy to help you think about what equilibrium means. Imagine that equilibrium is just a pond with some very still water, and you drop a stone in, and of course immediately you're going to cause a lot of ripples in the pond based on the stone being dropped into the water. As time progresses, though, you'll notice that the ripples will get smaller and smaller until eventually there aren't any ripples left, and it just goes back to being completely still. And think of that as your variable experiencing a shock, and then as time progresses, the effects of that shock diminishes, and then finally it's restored fully back to equilibrium. That's what should be happening. Okay, now bear in mind, this is what an IRF looks like in a VAR. Right, so you can see that it starts here. There are obviously some fluctuations going on, but ultimately looking at the shape of the IRF, you can see that eventually it converges back to 0, and that's essentially showing that equilibrium has been restored over a set number of periods. Presumably that was 15 time, well, yeah, let's say 15 time periods, judging by that axis there, the x-axis. And the thing is that when you do IRFs with a vector error correction model, the shape of your IRF is not going to look like that, and so as a result, equilibrium isn't restored. So what that really means is that because you're pushing in your variables in level form and therefore non-stationary form, when you apply shocks to these non-stationary variables, the effect of the shock is permanent. So to go back to our pond analogy, imagine if you dropped a stone in a pond and the ripples just carried on forever. It wouldn't really make sense. And that's essentially what's happening when you're uh, conducting IRFs on a vector error correction model rather than a VAR. That being said, um, if you're desperate to fill up some word count in your essay, you can include it, but you just have to be very, very careful about how you interpret the results. So very quickly, by the way, I'm just going to very quickly show you how to do IRF impulse response functions on Eviews. You click on View, you click on Impulse Response like that. Now you'll probably see all your variables go in there. So like say for me, I would have had like learn AHP there, and you'll have all your variables in the response section. Bear in mind that your dependent variable should just be in the responses box. So for me, my topic of interest as I was doing my dissertation was the effect of macroeconomic variables on average house prices. So average house price was always the dependent variable that I was looking at. That's why it's going to be the sole variable in my responses box. These variables here, loan M4, loan credit, IR, and the unemployment rate, these are my independent variables. I'm trying to assess how they affect average house prices, and so I'm putting them in the impulses box. Okay? And all I'm going to do, and we can change this up, we can change it to 32 periods, we can do whatever, but it suggests 10. And let's just click OK. Now look at the shape of that. Look at the shape of these impulse response functions. In fact, I've got a PowerPoint already which shows it. Look at the shape of that compared to this. Look, there's some fluctuation. It's going down, it's going up, it's going back down again, and eventually it's going to 0. But look at this. It goes up, it reaches a certain point, and it never goes back down to 0. So this shows you that the effect of the shock is permanent, and the effect of the shock is permanent because because if you think about it, none of our variables are in their that they're at level. In other words, I haven't differenced them. So if we wanted to difference them, we'd have to do something like this. But it doesn't work, unfortunately, when you do that. So bottom line is this is how they look. You can see they're all permanent. None of them ever go back down to 0. How do we how could we interpret them? Oh, by the way, just looking at this slide, they can still show us the sign of the relationship. So obviously the money supply has a positive effect. The credit availability has a positive effect. The IR has a negative effect, and the unemployment rate. And obviously these are based on our co-integration vector as well, presumably. That shows that it's got a positive effect, even though that's wrong. So the question is, how would you... Let's take this particular one that I've taken, this print screen. In fact, actually, I'm going to wrap it up here. I'm going to just quickly record a second video just showing how I analyze impulse response functions in the context of a vector error correction model. So I'm going to wrap up the video now. Okay, bye now.